Today we are going to talk about angles made by a transversal and two lines. We have corresponding angles, alternate angles, co-interior angles, and we will discuss the vertically opposite angles. So what are corresponding angles? These are angles made by a transversal cutting two other lines. The angles are on the same side of the transversal. One is between the lines interior and the other outside of the line's exterior. So let us look at this diagram here. This blue line is called the transversal line, and it is cutting this line and this line. So can I see the corresponding angles? Yes. This angle and this angle are corresponding angles. Sometimes we call them the F angles. Can I see the F? Let me draw it. This is an F. It's not a normal F that you know, but it is still an F that we use to identify corresponding angles. This diagram here, here's my transversal, line 1 and line 2, my transversal line. So which angles are found on the same side of the transversal and the two lines? This angle and this angle are called corresponding angles, and they are equal. There's a theorem, but I'll discuss that later. Can I see an F here? Let me draw it for you. It's not the normal F that you know, but it is still an F. So corresponding angles are also referred to as the F angles, so that it is easy to identify them. Another set of lines found between two lines cut by a transversal are alternate angles, and these are angles made by a transversal cutting two other lines. The angles are on either side of the transversal, and both are between the lines and their interior, their inside. So let us look here. Line 1, line 2, cut by a transversal line. So this angle is alternating to this angle. They are called alternate angles. And in grade 8, alternating angles are equal. Another diagram, line 1, line 2, transversal in blue. This angle is alternating to this angle. Can I see a Z here? Let me draw it. Yes, they are alternating angles. Let me draw another Z here. So this angle and this angle are alternating angles, and they are equal. They are also referred to as Z angles or Z angles. Let us now talk about the co-interior angles. What are they? These are angles made by a transversal cutting two other lines. The lines are on the same side of the transversal, and both are between the lines interior. They are also referred to as the angles in a C. So transversal line, line 1, line 2, and they're on the same side of the transversal. So this angle and this angle are called co-interior angles. Line 1, line 2, transversal, this angle and this angle are co-interior angles or angles in a C. Can you see a C here? Let me draw it for you. It's not a good C, but it's a C, and so angles in a C are supplemented. If you add them, this angle plus this angle, we get 180 degrees. This angle plus this angle, we get 180 degrees, but I'll discuss this later in the next slides. Let us do a quick revision on vertically opposite angles, which are angles found between two intersecting straight lines. Let us look at this diagram. Line 1, line 2, transversal line, and I have 2 points of intersection here and here. So let me discuss about this intersection or this intersection. So basically this angle and this angle are vertically opposite angles. Therefore they are equal. And this angle is equal to this angle. They are vertically opposite angles. So they are equal. Let us look at slide. Now I'm going to show you some angles on how to identify them. How do you identify the interior angles, the exterior angles, and possible pairs of corresponding alternate and co-interior angles? I'm going to give you line A and line CD and a transversal line EF. Where is line AB? Here. Line CD and a transversal line EF. What can you see and what can you conclude? I can see that angle 3, 4, 5, and 6 are interior angles. 3, 4, 5, 6. And which angles are the exterior angles on this diagram? Angle 1, 2, which are on top of line AB, and angle 7 and 8, which is below line CD. And how can you use these interior angles and exterior angles to identify pairs of corresponding alternate and co-interior angles? Remember, corresponding angles are angles that form an F, alternate angles a Z, and co-interior angles a C. So 1 and 5, 1, 5, 3, 7, 2, 6, and lastly 4 and 8 are pairs of corresponding angles, as you can see here. Alternating angles or alternate angles: 1, 8, 2, 7, 3, 6, 4, and 5. And can I see the pairs of co-interior angles? 4, 6, and 3, and 5. Where is my C? Angles in a C are co-interior angles. And if you add two co-interior angles, you get 180 degrees. It's a theorem which I will talk about later. The next slide. This is more of revision of what I've been talking about. Now, what happens if those two lines are parallel? So, given line AB and line CD, and they are parallel. What are parallel lines? These are lines which can never meet, or these are lines which have got the same slope. In the transversal line EF, what can you conclude, or what can you see? Angle 1 and 5, 1, 5, 3 and 7, 2 and 6, 4 and 8 are corresponding angles, and they are equal. Why are they equal? Because line AB and line CD are parallel. Alternating angles 1 and 8, 2, 7, 3, 6, 4 and 5 are now equal. Why? Because line AB is parallel to line CD. Co-interior angles. We have a theorem in grade 8 which says co-interior angles are supplementary. So if you add those two angles in a C, you equate the answer to 180 degrees. They are supplementary. Remember, supplementary, it means 180 degrees. So angle 4 plus angle 6, if you add them, the answer is 180 degrees. Why? They are co-interior angles. 3 and 5, they are co-interior angles. So what can we conclude? We can conclude that two line segments cut by a transversal line will be parallel if and only if the corresponding angles are equal, the alternating angles are equal, and the co-interior angles are. Here I've also attached the acceptable reasons in geometry. In my first video, I talked about some of them. Let's look here. What can you see? Angles at a point or angles around a point. It's a theorem that you need to know in grade 8. What can I see? Adjacent angles in a straight line. And you should be able to know this theorem, please, by head. Adjacent angles in a straight line are supplementary. Normally this theorem here is a converse of this theorem. It is not very popular in grade 8, but really important. It's a converse of this theorem, which we use to prove that a line is indeed a straight line. For example, if I add this angle and this angle, and I get an answer of 180 degrees, it means, or I conclude that line AB is a parallel line. It's a straight line. But not very popular in grade 8, but important in mathematics. What can I see? Vertically opposite angles, they are equal. Alternating angles, corresponding angles, and co-interior angles. Please learn how to write the acceptable reasons as written in our CAPS document. I've attached 2 examples to illustrate what I've been talking about. What can I see? I can see 2 line segments, AB and CD. So which theorem comes to my mind? Vertically opposite angles, they are equal. So the first angle, 2x minus 20 degrees and 134 degrees are equal because they are vertically opposite angles. You equate. And then you solve for x. I need algebra here to assist me. Minus 20 degrees comes this side, becomes positive 20. You add 134, you get 154. Bring down 2x. You need to remember what 2x is. It's a product of 2 and x. So what is x? Which number do I multiply by 2 to get 154 degrees? Obviously, it is half of 154, which is 77 degrees, or you divide both sides by 2. Last example, given the diagram below, calculate the value of x. What can you see? I can see a straight line. Line ABC is a straight line. I can see 90 degrees. So from theorem number 2, adjacent angles on a straight line are supplementary. It means x plus 37 plus 90 degrees is 180 degrees. They are supplementary. Why? They are adjacent angles on a straight line, and you can quickly solve for x. Thank you very much for watching. I hope you have enjoyed this video.